modulus x minus 1 equals modulus 1 minus x. The previous video proved this, but there was one fault in the proof that I used, in that I never picked a negative value for x to plug into the equation to check that it worked. So let's do an example to check that. Now let's go to the extreme case we used. We had 3x minus 5 modulus equals 5 minus 3x. So now we need to plug a negative value of x into this equation. Let's use x is minus 4. Okay, so we get 3 times minus 4 minus 5 all modulus equals modulus of 5 minus 3 lots of minus 4. So 3 lots of minus 4 gives us minus 12 minus another 5. Does that equal 5 minus... Now we could think of this as taking away 3 lots of negative 4, or we could think of it as negative 3 lots of negative 4, which would give us positive 12. So negative 12 and negative 15 gives us negative 17. 5 plus 12 gives us 17. So we've now shown that even if we use a negative value of x, this still equals this. Now this should account for these situations as well, but let's make a way of being completely thorough. Now this, we need to draw a graph. So we draw our y-axis, our x-axis. Now this is just going to be a sketch using x is minus 1 and 1 and minus x. So the equation in both cases has a gradient of 1 in this case, minus 1 in this case. Let's think about gradient of 1 first. So it has a gradient of 1 and the y-intercept is minus 1, so let's shift the line down slightly, label this as minus 1 and draw a line in. Dotted, because we know that we're going to have to account for the modulus in a second. So let's draw a dotted line for the next equation, 1 minus x. Well this, if we think about it in terms of y equals mx plus c, would be written minus x plus 1. So it's got a gradient of minus 1 and a y-intercept of plus 1. So now if I draw this line in, we get this. Now modulus means we only take the positive values, so these lines down here don't exist in the modulus equation. These points become positive, so where it's negative 1 here, it should become positive 1 up here. So this line for our x minus 1 would be all these values, but at this point it reflects and becomes all these points. So if we were to follow again for this equation, we would just be tracing over the exact same line. Follows this way, then all these negative values here become positive. So we have shown graphically now that x minus 1 equals 1 minus x.